Yeah, yesterday we have seen so we have seen that in a project where the WordPress and MySQL can communicate to each other, so that we are able to build an integrated application. Yesterday we have seen that. This is inside a project. This we have did it in the same project. Similar thing will happen in the between the different project also. So, for example, let us consider this is the cluster. This is the cluster. So inside the cluster, I have two different projects. So let me go to this one project and this another project. And so let me name this as project A, and this is project B. Okay. And there are some application. For example, there is a application here in project A, and it has got some service. Okay, so it has got some service, and there are some application in this project also. So this is another application. So let me say this is a pod, an application I call this as my app, and there is a service for it. And let me say this is another application. So just name it just as a test app. That can be any application. And what happens is you can able to communicate from this project, but through this application I can reach this application. I can able to communicate with this. The communication can be anything, like it may be a front end. I'm just going to use this as a backend. So the communication means maybe anything. So I can directly communicate to this application. This, because we know that every pod has an IP address. So internally, from inside this application, I can communicate to the application which is over there in the other project. And also I can reach the same application through the service. So this is another means. So the difference is when you reach through the service, what happens is when this application is scaled. So for example, if I have the same application replicated another time, so for example I have my app. So when you reach through the service, so there will be a load balancing happening over. So the service, what it will do, it will load balance a request between these two apps, so which is a scaled app. So it will do that, but when you reach it, reach this one particularly, so you will be able to reach only this part, not this one. When you go through the service, you will see that you can reach this. So when you first reach the first time, 2 or 3 times after, you can see that it will roll balance a request to the different part. So this is what the thing. So this is called inter-project communication. So between the different projects, you can call inter-project communication between the pods or between the applications. And in the network communication, we are going to mainly focus on this. So there are a lot of things are there in the network policy. You can focus on the application in the same project itself. So I can able to control the application within the same project. For example, the previous scenario where these two applications can talk to each other by default, I can control this. For example, I can limit this. So inside by a multiple application, I can control that one application from talking to the other application. So that is intra-project communication. So I can control that. Also I can control inter-project communication. So I can do that. So we mainly focuses on. Also, you can control the application from the external access also. So externally, I want somebody is accessing my application from the external world. So I can do a control from that also. So external communication control, I can say external project communication. So that is also we can control it. But here in our curriculum, we are focusing on inter-project communication. So how to restrict the communication and how to allow the communication. This will be our focus. So we first will see how to restrict this communication using the network policy. After restricting it, how to give access to a particular application. So I restrict it universally so that nobody can access me. Then what I will do, I have to give access. So there may be some need for some application to access my application in the different within the different projects. In that case, how I can allow access to that particular application only. So that will be our focus of study. So even though we have a lot of things on the network policy, we can configure in multiple different ways to use that network policy. But here at the introductory level, so we'll see how to use network policy. Once you understood the concept, then you can apply the same concept to multiple ways, or you can say multiple dimensions. You can apply that same network policy concept. So we are going to just see in one dimensional way. We are just going to limit or you can say limit the inter-project communication to the network policies. So we'll see that with an example. So already we have one project called my demo 4. Inside this I have an application. I'm going to build another project. I call this my demo 7. I'm going to build a test application over here. To the test application, I'm going to access this application which is already there in the my demo 4. So we'll go to that. So let me go to the lab. So let me verify into the cluster. I'm the cluster. So let me now get this project, OC project my demo 4. So we already used this project for some demo purpose. So I can see get ports. So we already scaled that application. You can see the application which is already running, the my app application. So I'm going to create this project and I'm going to see the control. Like I'm going to see the default communication behavior. So defaultly, without any see what happens is this application which is over here can communicate to this without any restriction. So we can see that. So I will create a new project. See new project. I'm going to say my demo 7. I've created this project. Inside this, I'm going to create a test application. Let me create it. So we see new app. Let's say I don't name. Let's say this is a test app. Here I'm going to use a Docker image. I'm going to get the image from DO280. So you can get it from any repository. Just we are mainly using this so that these images are suitable for our particular concepts or particular study of or particular demonstrations. So I'm specifically choosing from the image from here. Here I'm going to use Hello World Nginx. Well, Yeah, now I created this test app. Let me see OC get pods. Now this test app is running. So the current project is my demo 7. So now we will test this condition. From the test app, I need to see that this applications are reachable. Like I need to reach this my app application through the service. I'll try to reach through the service as well as I try to reach through the directly. So I want the information about that pod IP address as well as I want to get that service IP address or cluster IP address. I just give OC get pods. I can go white. My demo port. So now you can see the IP address of that pods, and then I'll just get OC get service. So I'm going to get that from this project, my same demo port. Now I'm currently in the my demo 7 project. So from this here one application is running, so the test app. So I'm going to get into the test app. Now I'm going to do OC RSH test app. So I'm getting inside this into this application. So from here I'm going to do a curl. I'll be using the IP address. So this uses the port. So yesterday we have seen was using the 8080 port, or you can see in the service it was linked to the target port as 8080. So I'm using that to curl it. Now you can see I get the reply. If I use this IP address, I can reach this pod also. You can see I'm able to reach this particular pod. And now I'll try to reach the application through the service IP. I'll just do a curl. I just use the same port number, which is 8080, that is the service port. I'm going to reach it insecurely. So this is exposed in 2 different ports. So if I do now, you can see I can able to reach it, and you can see the load balance. The first time I reach it, I'm reaching one pod. Next time I'm reaching it, I'm reaching the second pod. This is I'm reaching it from inside this application. Yeah, I'm inside this application, so you can see the communication. So I was able to reach through the service. Service is doing a load balancing. As well, I was able to reach it individually. So individually, I can able to reach this application. Now, so we are going to restrict the communication. So this is our thing. So I don't want any application to communicate to me. Maybe this my app may be a sensitive application. So it may be a database application. I don't want the other application to communicate to me to get some information or something. So in that case, how to restrict it? How to restrict this communication? So we are going to use the network policy. So network policy can be written in multiple ways. So here we are going to see that first what I'm going to do is I'm going to entirely isolate this. So I'll be forming an isolation here with the network policy, so that this communication is restricted. So previously this communication which is happening over here, so I'm going to restrict this communication so that you cannot able to reach this even through the service, as well as you cannot reach directly through the pod. So I'm going to restrict this communication. So after restricting it, and so this I'm going to write a network policy. So after restricting this communication, then what you can do is, so this policy I'm going to call it deny everything. So you can give a name for the policies to identify. So naming you can give anything. So I'm going to call this as deny everything policy. So deny everything. So deny everything policy. So that this application cannot reach this one. So not only this, any application cannot reach this from any project cannot reach this application. So the address will be completely isolated. So after writing this policy, then I'll try to reach. After this policy is written, So universally it is now protected, so nothing can reach this application. No application from different project can reach it. Then I'll give a specific access. So some application may want to communicate this. There may be some requirement. In that case, I'm going to see how to give a specific for a specific application. Only a particular application can communicate. Other application cannot communicate. So I'm going to see only a particular application can communicate. So I'm going to see how to use that. So here I'm going to write the network policy. So the policy you have to write in the project where you want to control that communication, where you want to restrict the communication. So I have to go to this project, which is my demo 4. So you have to write that in a declarative format. So already I'm just going to use some already existing files to write that. So I'll go to this. So here I already have a file. So this file, using this I'm going to write the network policy. So network policy we cannot do it in the command line. So the policy you have to write in the declarative format. You have to write in the file format. So here you can see the kind is network policy. So the version API URL link, you can see this is the version, and the metadata. So here I'm giving the name. So you can give any name. So here I'm going to say deny all, or you can say deny everything, something like that. So you can give your own name to just identify the policy. And next comes the under specification. Here comes the port selector. Under the port selector, later on we'll see that you can give a specific access here. If you don't mention anything over here, if you just leave it as empty like this, what happens is completely in this project, this pod will be isolated. So not only this pod, whatever the pods are there inside this project, it will be completely isolated. Isolated in a sense, from the different project, you cannot able to communicate with this. So it will be completely isolated. When you leave this as empty. So this is what the meaning of denying everything. So it will deny every communication from the different project. So I'm going to deny everything. So I'm going to write this policy. So here I'm currently in the project my demo 4. So here I don't have any policies now as of now. So see project, so see get network policy. So I don't have any policy here now. I'm going to create a policy. OC create -f. I want to create that policy, deny all. So the file, I'm just pointing it to the file. So this will accept that file and will create this policy. Now this policy is created. So now if you see, the policy will be in place. Like you can see, deny everything policy is there. So here there is nothing, there is no port selector. So I'll go to the next terminal. So now I'll go to this project again. So my demo 7. So here I'll get again that service IP as well as the port. So from this project, my demo 4, then I will get this as well as the service. In the same project, I'll get the service details, service ID, and I will try to communicate. So now I can say I'm getting this one, and then I'll do a OCRSH in the test app. So because inside this project, my demo 7, this is test app is there. So here now I'm going to do a curl again. So I'm going to do curl. So I'll take this IP, and I'll just try to do 8080. You can see that now this is not reaching. So the network policy is now preventing me from accessing that application. So this is not reaching. So through the direct pod IP address, also it will not be reachable through the service also. If I just do that using this service IP address, the previously it was working. So now I just try to do that. So you can see that it is not working because this policy is in place. That's the reason why it is not working. If I delete this policy, I just go into this project again. So if I delete this policy, which I have already have network policy, if I delete this OC delete network policy, the name of the policy is deny everything. So if I delete this policy, then I come back here, and now you can see this is going to work. I can see that I am able to reach to the service. Also I can directly reach the phone. Now it is working. And if I place the policy again, if I implement this policy again, now that communication will be restricted. So if I just create this policy again, then now the policy is created, then you come back here and try to reach it again, you'll see that communication will be restricted. I cannot reach it. Now you can see that the communication is hanging because the policy is preventing that application from reaching it. And I can just reach it through the service. So you can see that it is not working. So if you delete that policy, it was working. So you can see that you can reason it like because of that policy, I'm not able to communicate with this application. Okay, so this is how that network policy works. Now I want to give an access. So now I want to.
Abdul, just a minute. Can you just go to the other tab? That one, yeah, and the network policy. So actually, while creating the policy, you're saying OC create -f deny all.yaml. Okay, but deleting the policy, you said denied everything. What is the reason?
This is the policy name.
Okay, that is deny all.
Deny all is the file name. So whatever the name which is there in the file, that is the name with that the resource will be created. You will have to refer to that resource. This is just a file, so it will not create in that file name. So when you look at this file, so whatever the metadata you are giving in that file, so this is the name you have to refer. So this is the name with which the resource will be created.
Okay. So while creating it, you have to use the file name, and deleting it, we have to use the name of the network policy.
Yeah, file is just a transit agent, so file will not be referenced later on. File just is a transit nature, the transit agent, because file name will not be referred after that. So it is for our reference. When just you are pointing out to the file, you refer to the file name. Whatever there in the file content, so metadata, so whatever the specification writing, that is going to take into that. So that is the resource which will be created. So when you want this resource will be created in this name only. It will not claim in the file name. Maybe sometimes the file name and this may be same, but file name is just for the reference, or you can say transit only. So just to read that file in my local system, I have the name. But the name which you are mentioning inside that file, in that name only the resource will be created. So when you want to do any operation on the resource, like deleting or creating or modifying something, you have to refer to that name in which it is created. So that's why I showed you here the name is deny everything. So when you want to delete, you want to do the delete operation, you have to do that OC delete name of that.
Okay, got it. Thanks.
Okay, and now I want to give access. So maybe I have another application over here. So this is test app 2. So this is test app 2. I want to give access only for one application. So maybe I want to give access for only this application. So this application should not reach it. So not only this, only from on a particular project, I want to give a particular access. So maybe I want to give access to only this pod. So this pod, only this pod should just access it. So from here, it should reach to the service as well as it should be able to reach to this. And when this one tries to reach it, so it should restrict it. So now what we have did is we have universally restricted it. So any application from any project cannot communicate to me. Now I'm going to be specifically giving access. So this is what we're going to see. Specifically giving access to this, and this method you can apply to any project. Like you can, if you understood the concept, this can be extrapolated. Like you can be extended to any project. For any, if you are having any project, in that project you want to give an access for that particular application. Same the network policy, which the methodology which we are going to use for that which we are going to use that to write the policy, you can extend to that. Okay, so this is what we're going to see. So I'll be back to that. So before writing that policy, I need to identify some information. So that is required. Informations like I need to identify some labels. So how to identify things. So for example, I want to say from this project, I want to give access to this application. How to identify this application uniquely, and how to identify the project uniquely, and how to identify maybe in the same project, the project my demo 4, I may have another application also. In this project also, I have to identify which application I want to give access. So I have to uniquely identify each application. So who is going to help me to do that is through the labels. So we have seen that every pod will have a default through the deployment. We are labeling the pod. So every pod will have a label. So using the labeling, so pod as well as the project. Project by default, project will not have a label. You have to label. We have to assign a label to the project, and pod will have a label. So using that mechanism, so I'm going to give access so to this application. So how I'm going to give access is first I have to identify the current project for which application I want to give access. First I have to identify that application, and second thing, I want to identify the port because I want to give give access through the service also. So for identifying the service, I need to give the port. So through which port I'm going to access this application. I have to identify the port, and then I have to identify from which project I'm giving access. So from which project I'm giving access to, from which application. So first I have to identify the project, and I have to identify the application for which I'm giving access. So I have to identify these things. So I'll just so I'll get into this project. So I'll identify these things. The first is the current project. So I'll go to the OC project. So I'm going to write the policy. Before writing the policy, I have to identify these things. So once you identify these things, it's easy to write that policy because this information is required when you are writing the policy. So I'm going to this port. It may be currently I'm already there. So here I need to get the label of the application for which I'm going to give access. I'm going to do OC describe pod, and the name of the pod. This is my app. And here I may have 3 pods. So all the pods will have same label. So I can just take one for an example. I can here grep for the label. So it has got a label here. You can also label it if you want to label it in a different way, but here this label, the default label will be sufficient to identify it. So this is the label. So this can be anything in the real time. So here it is deployment equal to my app. So this is the label. This is a key. So when I say label, it will have a key value path. So this is the key and this is the value. So this is the pod for which I'm going to give access in the current thing. And I need to identify the port also, like OC get service. I will get the service name will also be my app. I will identify the port because this is also required to write the policy. I need to mention the port. Just try values, get values describe. So the port are exposed in 2 different ports. I'll be using this port 8080. So this is secure port. I'm going to use this insecure port 8080. Then I have to identify the label on the other project. So I have to first identify from which project I'm giving an access. For example, I'm going to give access from this project. So I have to identify the label of this project. So this project, so you can identify the label by using OC describe project, name of the project, my demo 7, grep for the So the project is not having any label. So as a default, it will not have label. So we have to label that project. So we have to use OC label command. So OC label, so I have to say this project as namespace. I have to refer to that Kubernetes term, namespace. Then the project name is my demo 7. So here I'm going to label it. The label you can give anything. I'm going to say project equal to my demo 7, or you can say name equal to my demo 7. Anything you can name it. So I'm going to say project equal to my demo 7. So now this is labeled. Now if you look at the project, I can see it has got a label, project equal to my demo 7. Then I have to identify, so in that project I have to identify the label of that pod for which I'm going to give access. So I'm getting into that application, getting into that project, my demo 7. And here I'm going to do a OC describe pod. So here the pod is test app. So here I'm going to grep for the label. So here the label is deployment is equal to test app. So we are just identifying the labels and the ports. So I required the current project. So I'm going to write the policy in my demo 4 only. I'm going to write a policy. In that policy, I'm going to give access for this particular application to reach this one. And I'm going to write a policy over here. So for writing that policy, I require this information. So what are the information required? The labels. So to uniquely identify some resources, I'll be getting the help of the label to uniquely identify. So I'll be getting the label of the current application for which I'm going to give access, and the port is required. Then I have to identify from which project I'm giving access. I have to identify that project through that label. So defaultly that project is not having a label. So through this command you will going to label that project. After that, the label is assigned for that project. Then you will identify in that project for which application you gain access. You are going to identify that through that label. So after identifying this, then we can go and write the network policy for that. So here I already have the file. So just I'm going to modify this file. So if you want, you can real time you have to write this file. So here just I'm going to modify the labels. This is a sample file. So here I'm going to name this allow. The name you can give anything. So you can say allow specific access or allow specific pod. In that, then under the specification in the pod selector, now we can see I'm going to match the labels. The first label is on with reference to the current project. The current project for which I'm going to give access. So I'm going to reference that label here. So here we have identified the label to be deployment equal to my app. So this is the label of the current application in that project, my demo 4. So here I have to mention that. So here I already have a label. So this label I have to change it. So here deployment should be my app. So the label when you are mentioning, so here it will be like key value pass, like you'll see the equal to sign, equal to operator, you can say. But when you are mentioning in the YAML format, you have to change that to the key value pass, like the dictionary format, like you have to say colon. So deployment colon my app. So you should not use equal. Equal operator will not be working in the YAML syntax. Then I have mentioned that label. Then from which namespace, from which project I'm going to give access. So that label I have to mention. So here match labels. So here I have to mention the namespace. The namespace is the project. So I'm going to give you access from this project. So I have already labeled it. So I have labeled it as my demo. The project equal to my demo 7. This is the label. So this label I have to mention over here. So here I'll remove this entirely. So here I have to mention the label as project colon my demo 7. So just I move back to the original space. So project this is a label project colon my demo 7. And in that project, for which application I'm given access, the pod selector here. So here I may mention multiple labels also. If I want to give multiple applications the access, I can write this in the multiple formats. So here I'm just going to give one application. I have already identified that label, which is this one. So the test app, for the test app I'm giving access. So here the label is deployment is equal to test app. So here I have to change this label to deployment test app. So then the port is already identified. The port is 8080. So this is the port which the container port which is 8080. So I'm specifying that port over here. Then I'm going to save this file. Just a file. So this is not a policy by itself. It is just a file. I need to create that policy. So inside that project. So let me check my current project. My current project is demo 7. I should relocate to the project my demo port. So here I have to create the policy. So already I have the policy which is the deny everything. So deny everything policy. Now additionally I'm going to create this policy. This policy is going to give access for me to get that application. So here I'm going to create that okay. Before creating that, I also can get here and go to this project service as well as the pod. Now if I curl it, you see that curl will not be working because the deny everything policy is in place. So far I didn't create the allow specific, so I deny everything is in place. So I can see this is not reaching. It will not reach directly. If I try to reach through the IP address, this is not reaching. So I have to come back here to create that project. So here let me create that OC create -f. I point out to the file is allow specific. So I'm going to create this policy. Now this policy is created. Now you have the two policies over here, and I come back here and check that now. Now you can see this is, so I can reach this because I've given access for this specific application. Now this can reach. If you delete this policy, allow specific pod, if you delete this policy, this will not work. Then this will take into the effect, the deny everything. So that will take into the effect. You can check that also. You can just do OC delete network policy. So if I delete this policy, so you can see now if you go and check here, if you try to curl it, you'll see that curl is not working because of this policy. Only that specific thing is getting allowed. So you can create another application and also check. So I create this now, this policy, and only this application is allowed. You can see now it is reaching. I can directly reach it as well as through the service. And now what I can do is I can create another application. So I can create this scenario where I can create another application, and if this application tries to reach it from here, this application tries to reach it, so what happens, this will be prevented. So this application will be prevented from reaching it, so it cannot reach it, so this will be prevented from here. So we can verify that. So only this application reach it because we have written the policy for only this application. So we are very stringent in the condition that only one application can reach it. So here I can get back to that project again. This is my domain 7. So here I have only one pod, let's go to pods. So here I can create another application. Just this one. I can name. Here I'm going to save test app 2 and use the same paper image DO280 flash and same image I'm using. So here now I have the same project. I'm going to have two applications running here. So through the one application I can reach it, but through the other application I can't reach it. So here you can see now. So OCRSH. I can able to take my app and test app. The test app list, I'm going to pick the first one. So through the first one I can communicate. I can reach that application using the directly the IP address as well as the pod, because the policy is going to allow me for only this application. You can see now it is reaching. I can even reach to the service. Okay, so if I do the same thing by getting into the second application to see remote shell, and I'm going to get into the test app 2. So if I get into this application, if I curl this again, the same one, you see that I'm not able to reach it. So the curl is that particular connection is hanging now. Even if I try to reach it through the service, I cannot able to reach it because I have given access only for one application in that project. Okay. So if you want to give access for any project, so for any application is any project, you have to write this policy like this. So once you deny everything, so everything will be completely stopped. So you cannot able to reach it reach application inside from like you can the inter-project communication completely stops. Then you have to specifically write policies. So if you don't write the policy, then you cannot, without the policy you cannot access it. So you have to take care of that one. So when you're doing deny everything, so that means you can never communicate from any application inside the cluster, or from any project you cannot communicate to this. So if you want to communicate to that, so you have to write a network policy. The same policy, though, you have to identify the things. So from which project you are giving access, you have to identify the current pod, you have to identify the pod from which you are giving access, the project, then the port, and all these things you have to identify and write a policy, so that the policy will help you to reach that application. I hope now the concept is clear. So
yeah, can you please open that YAML file, network policy YAML file? That allows specific. Okay, so here that under the increase, so we selected only for deployment test app tag only, right? So whatever the pods having that same tag, so those pods we can able to reach that application, so reach that my app application, right?
Yeah.
Okay.
The labels, labels should be same. The labels are same. So pods, different application will uniquely have different labels.
Okay. So what is the label of test app 2? Recently you created one test app 2. So what is that label of test app 2? So if I add the test app 2 label here, test app label into test app 2, then it will that part can able to reach that my app type.
Yeah, you can identify the label. So that label command, I think. Let's see, describe pod. The label will be just almost like deployment is equal to
Blanca.
test app 2. So when you create through the new app, almost the label will be like this. So it will be like deployment something. So when you create your own declarative file, the labels you can give your own labels. So like yesterday we have done that. So now is
Like as
creating
endpoint, yeah, like as endpoint services endpoint, so we can make labels common for all multiple pods. So those pods can able to reach that application, right?
Yeah.
You can able to provide information. Okay.
Yesterday when I was creating the declarative file, so the label I was mentioning here, this is actual label which it is taking. The labels, whatever you mention here, so that will that pod will have the label of that. So if you want to change the label, so you can go and change that label, or can declaratively when you're creating that application. And also you can give multiple labels. So it's not to only one label you can give. You can give multiple labels here. So using that also you can refer to that.
Yeah, got it. Thanks.
Yeah, Abdul.
Yeah.
Yeah, Abdul. Actually, when you see that the deny, right, deny YAML file, so does it apply on both ingress and egress?
Yes. Yeah.
So because we never mentioned in our YAML file, so it applies both ingress and egress, correct?
Yes. The external communication will also be affected. But what happens is here we cannot able to see that the lab environment. If I go to the OC project, my demos code. So here I got the route. So here I have the route. So in the real time, what happens? So this will also be getting affected. So, but here you can see I can reach it. One time I can reach it. Another time it is not reaching. So I can see the error. So the application is not available. So like this it is getting. But in the real time, what happens? Even this will be like this will be also getting affected. So it will not be reachable from the external world. So to overcome that, we have to write one policy, which is the default project. You have to label that default project, and by labeling that, you are going to overcome this issue. So this issue is that in the classroom environment, we are not able to see that. Here you can see because the we are inside the worker node itself. So sorry, the master node itself. So we are not able to observe that process. To allow that, so what you have to do is you have to write a policy. So in that policy, allow specific from the OpenShift. That allow specific from the ingress OpenShift. There you have to mention that policy here. So particular policy and the group policy. Then you have to label that group policy over there in the default project. So what you have to do is, so there is a project called default project. So if because of that deny everything, what happens is the external communication also affected in some way. So you can see now I can reach it one curl, when I reach it one time, it is not reaching. When I reach the second time, it is actually reaching. So what we have to do to overcome this thing is that there is a project called default. So if you go to this project, default, so here you can find one service. Here it's where the Kubernetes service is actually running. So here you can find the Kubernetes service. So if you look at the endpoints, OC get endpoints. So these endpoints will point out to the actual IP address of the nodes, which are there, which are the master nodes. So what I have to do is I have to label this default policy with some one specific group label, and I have to mention that label inside the policy in that project. So then this will be working properly, because this is where my cluster main ingress point is. So this is actually the service. So my service endpoints are the actual IP address of that nodes. So if you look into the nodes, so here we have the nodes. So if you look into the IP address, this will be the same IP address of that node. You can see that. So this is the same IP address, 50.11, 50.12. And this Kubernetes service is which is there in this default project, has to be aware of this. So I have to mention that I have to create one more additional policy to rectify this issue. So that it works externally also. The external communication now it's partially affected. To overcome this issue, I have to what I have to do is I have to label this default policy. So default policy will not have any label now. So we see describe project. So default actually default project. So default. So here it is not having a label. So I have to label this project, and this project, once you label it, the label parameter has to be mentioned in the policy. So you have to write one more policy, which is going to allow you to control the external network also, external network policy also.
And one more doubt, actually, first you initiate that deny policy, next you allowed for the specific port selector. So for now, what happened is my question is, so you now you allowed one. For example, you denied. I mean, you removed the deny all. Okay. So now you are allowed only for the specific port. So now you can add that deny all. So which one it will take in place? Like which one it will select? Whether deny or it select the second one.
No, the both are in play. Both are taking together. Like the first one is denying everything. The next one is just allowing one specific thing. Both are working together.
So there is no order, right?
Yeah, both are working together. I showed like when I delete that policy, the deny all will be ineffective. When I delete that allow specific policy, deny all will be ineffective. So
because first because the first priority now is denial, right? So after that only you are allowing specific one. So it will not check the first one. Okay, deny all. So we can reject. So not like that, right? It will check other policy also.
Yeah, that should be like logically it should be understood. Like you have to deny everything, then you are going to allow specific. So if you don't have that deny everything, allowing specific doesn't have any meaning, right? So logically it will be conflicting, because I'm allowing specific thing, so there is nothing preventing my access. So previously I have shown you, without the deny everything, the communication happens by default. So everything can communicate to me. So once I deny everything, then there is a requirement for specific access. So if I don't deny everything, then there is no requirement for specific access, because everything can communicate, right? So specifically you have to deny everything, then you give a specific access. That's going to be logical and meaningful. Otherwise, just writing allow specific, because there is no requirement. If you don't deny everything, there is no requirement to allow a specific. So you have to see that both the policies have to work together. So
yeah, I thought that first deny is there. Okay, we can deny, so no need to allow the remaining one like that.
Yeah.
I thought.
Yeah, you can leave as it is when you can deny as it is like that. But if you deny that, there is a requirement for you to reach that application from any other pod, then you can write that policy.
Okay.
And other thing, both policies will work together. And now also we are going to write one more third policy. The third policy, we are going to rectify this issue, that the external communication. So with respect to that pod, external communication is also affected. So we are going to rectify that issue by labeling the default project. The reason for labeling the default project, because default project has this Kubernetes service, which is the actual service, which is referring to the endpoints, the actual node endpoints. So this service I'm referring to here. So here I'm going to label this with the annotation label. So this label I have to, with that label I'm going to create another policy in that project. Then you will see that it will be working. The external communication will also be working like in a smooth way. So because that deny everything affects the pod's communication in all ways, so external as well as the internal, all the things are getting completely affected. So just to see that everything works, we have to write that policy to make it this thing. So when you're writing the policy, so it actually makes our life difficult, like for that pod. But if it is a very sensitive information, very sensitive application, then we go for these things. Because once you deny everything, then you have to write policies to allow it. So when there is a requirement, because it affects the external, internal, as well as all the communications are completely affected with respect to that application. Then you have to allow with the policies, and you have to write the policy and all these things. But this will make your application more secure internally as well as externally. So here I'm going to label the OC label. Namespace, I'm going to namespace the default. Here I'm going to label it as I have to, this is actually called something called annotation. So annotation means it's similar to labels, but annotation falls in a hierarchy. So label doesn't follow in a hierarchy. Label is just a key value pair. So here it is like in a hierarchy. So this is like you can say a link. So I'm going to annotate this project. So with this particular annotation, so I'm going to say this is network OpenShift .io. Then I'm going to say the policy group. I'm going to say ingress. So I'm going to annotate this. So after annotating this, now you can see now this project will have a label like this. So this one I'm going to mention inside the network policy. So I'm going to write another network policy. There I need to mention this. So I'll just go to that project. So it's the project my demo 4. So here let me go to that. So here I'm going to write in this one, this policy, I'll just change this one. So here I just mention all the pods. So and here I'm going to match that label. So label which I named with the default project. So I'm going to match this label over here. I'm going to save this. So I'm going to create another policy, OC create -f allow from specific this. So when I create this policy, so OC get network policy. Now I have three policies over here. And the last policy which I have created is for the external access. So in this project, I have got a route. So OC get route. So when you call through this route, so they should actually work properly that with respect to that application. I'll do a curl. Now you can see the curl is working properly. When I don't have this policy in place, what happened? The curl will not work properly. So one curl will reach that application, other curl will fail. So actually, in reality, actually it will fail. All the curls will fail. All the whatever the URLs you are using, that will fail. But here it is passing because one is passing and one is failing because our router, which is there in the master node, and the same master node itself acting as a worker node. So that's why it's one time it's reaching, other time it's not reaching. But in the real time, when the worker node is separate, the master node, which is called also as an infrastructure node. So both infrastructure as well as the compute node are in the same, are acting as the same node. So that's the case, it's passing. So in real time, it will not pass actually. So in that case, you have to write this policy. So this policy you have to, like, it's a procedure to follow it. Like you have to name that default namespace. The reason for default naming that default is a default namespace where it's actually the Kubernetes service is running. So we have to label that namespace, and after labeling that, the same label you have to create one policy, and that policy you have to create it, and that is going to allow you to do that smoothly. So for example, if I delete this policy, so we say delete. If I delete this policy, then if we try to curl now, you can see one curl will reach, another curl will fail. That's not reaching. So one curl, other curl will reach, and second curl will fail. So if you create that policy, so that policy is going to allow you to reach that application. So if you do that, you can see that now this will work smoothly. Okay. So with that, so there are a lot of things we can do with the network policy, but here just we are seeing how to allow that. So network policies, through that we are going to see how to control the inter-project communication. And when you are doing the network policy, it is indirectly affecting or directly affecting the external communication also. Without affect to manage the external communication, we have to write this policy in place so that you are just taking care of the internal things. The external thing is all automatically taken care by that policy. Okay, so with that we come to the end of this section, and here there is a lab, page 154, and to that lab. So you are going to do the same thing, like we are going to create a project. You will create two different projects, and in one project we have two different applications. So here instead of getting this information, I just was typing I was giving OC get pods -y like that. So here they have given a script. So if you run the script, it will just give you a summary of your project. So what are the services there inside that project? What are the pods are there? What is the route are there? The routes inside that project. It's just, if you run that script, they have given a script. If you run the script, it is going to show you that information. So here you will see, first you will see that you will create two projects. One project is called network policy, the project name will be network policy. Another project will be like I think sample project or network test. So you will create another project, network test. Inside the network test, you will create some sample application. First, you will try to reach that application from the other project. Then you will write the network policy. So you will write the network policy over using this, and you'll see that once you deny everything, then you try to curl and you try to do a OCRSH, that everything will fail, and then you will try to give a specific access. So identifying the labels. So only thing you have to label the project, but the pod and these things will have default labels. Using that, you will do allow specific access, and you'll see that then after allowing specific access, the application should be reachable. And also you will modify the second thing, like the external access. Also, you will write the external access policy so that you can able to reach the application from external, external curl. You can do that. Okay, so with that we complete the 5th chapter.
Yeah, Abdul, can you show that the OpenShift ingress YAML file? Just want to see.
Sorry?
Can you open that OpenShift ingress YAML file? Just want to see what is there inside.
OpenShift, which file?
The YAML file, the policy file. The
Which
OpenShift
policy?
ingress YAML, right? The
Ingress.
OpenShift ingress policy. Can you give a cat? The allow from OpenShift -ingress.
This one?
Yes, sir.
So in that one, that ingress network OpenShift IO policy group, right? So that is the tag, I mean label, correct?
Yeah.
So this label is applied for all the master nodes or all the node, including work nodes. So how in real time scenario, so where we have to apply this one?
This master node, it's not the master node, you're just labeling the default project. So I'm using this label on the default project. So the reason why I'm labeling it on the default project, if it was to say describe project default. So if we grab for the label, so you will see the same label over there. You can see the label. So I'm applying the label to this project. So this will once you label it, so it will reference the default project. The reason for referencing the default project is that the default project we have here the service for the Kubernetes service, the main service. So here we can see OC get service. So you have here the Kubernetes service. This Kubernetes service will reference the master nodes. Here, if you do OC get endpoints, the endpoints are the master nodes. You can see these are the master nodes. So this is going to allow the access. So once you reference this inside that policy, it will refer this default project. So this is called something like endpoint publishing strategy. They have used this strategy for the like you can say installing that OpenShift. So there are many strategies when it comes to the application. So this is called so this is specifically we are doing so that it is because it's following that endpoint publishing strategy. For that reason, we are specifically labeling this.
Yeah, I got your point, but so what I'm asking, so here that Kubernetes service, it's going to endpoint with all the master nodes, correct?
Yeah.
So in case if any parts are running in work nodes, then how can we expose to outside, external?
No, the controller will be in the master node only. So we are referencing the ingress controller. So So this is the default ingress controller uses the host network endpoint publishing strategy. So the controller will be the master node. Only if it's sufficient to mention that in the master node, that particular thing. So only this is going to reference the master. So worker node we need not worry about. So once you reference the master node, so that automatically it will allow that access. So you have to refer to the infrastructure node.
No, we deny for all the worker nodes also, right? We can able to deny with all the worker nodes also, right? Wherever the pods are running, we can deny it, right?
Yes. Yeah, wherever you're running, the pods are denied, but the external communication depends on the master node. So it depends on the master node controller. So that we are allowing that for the master node only. So it's not like the worker. We are not referencing. We are in no place we are referencing the master or worker node like that. But this policy which you are writing, it will reference the master node only. The master node because the controller is on over there. So it is enough to just mention that create that policy. So this is going to allow that. So here we are seeing that the external communication is not affected with that application. So no need to mention the master or worker node. Here just we are even if you look at the other policy, there we are not referring to any master or worker. So we are just referencing the whatever the available conditions, like through the labels we are uniquely identifying the pods. Then we are doing that. So I think no need to confuse with the master or worker node. But here the strategy which we are following is that on the master node, because the controller basically will be on the master node. So if you just mention that policy and if we create it, so that will be fine.
Okay. Slightly confused. Yeah.
Okay, so we'll start back. Finish that lab and we'll start by 11:20. We'll start back.